Now we will discuss the examples based on probability. So take this first example. What is the probability of getting tail in the throw of an unbiased coin? So when a coin is tossed, the sample space omega becomes h and t. So therefore probability of getting tail, so there is one case which is favorable to tail. As you know the definition of probability, probability is the favorable cases divided by the exhaustive cases. The exhaustive cases are 2 and one case which is favorable to tail. Therefore probability of A is n of A divided by n of omega. So that is 1 divided by 2. So 1 divided by 2 is the probability of getting tail in the throw of a unbiased coin. So take one more example. So two fair dice are thrown simultaneously. Let x denotes the number on the first die and y denotes the number on the second die. Write down the sample space omega and compute probability of x plus y equal to 10, and the second one is probability of x equal to 1. Two fair dice are thrown simultaneously. When one die is thrown, total number of cases becomes 6. 1, 2, 3, 4, 5, 6. But when two fair dice are thrown simultaneously, the total number of cases becomes 6 square. So that is 36. So what is the sample space in this case? Sample space becomes 1, 1, 1, 2. So likewise 1, 6. And finally 6, 1, 6, 2, 6, 3 and 6, 6. So these are the 36 possible cases. And what this 1 stands? So this first one stands for the result on the first die, and this one after comma, so there is again 1. So this stands for the result on the second die. So likewise, what is this 4 and 3? The first 4 represents the result on the first die, and this 3 represent the result on the second die. So these are the possible 36 cases. So the sample space becomes this. Now we have to compute the probability of x plus y is equal to 10. So what is meant by x and y? So x denotes the number on the first die and y denotes the number on the second die. So this means the number on the first and second die should be 10. What are the possible cases in this case? 4 and 6, 5 and 5, 6 and 4. So this is the first one, this is the second one, and this is the third one. These are the 3 possible cases out of 36 cases. So therefore the probability of x plus y equal to 10 becomes 3 by 36. And what is the second one? Probability of x equal to y. Means the result on the first die and the result on the second die, they are same. The possible cases are 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. The favorable cases are 6. The total number of cases are 36. Therefore, the probability of x equal to y is 1 by 6. Now take one more example. So one number is chosen at random from the set. So this is the set given. This is the sample space given 2, 3, 5 and 7. Then what is the probability chosen number is given? So out of these 4 cases, there is one case which is favorable for even number. So the total number of cases are 4, but 2 is only favorable for a even number. Therefore the probability is 1 by 4. So a fair coin is tossed twice, then the probability of getting 2 heads. So when it is tossed 2 times, what are the possible outcomes? The possible outcomes are HH, HT, TH and TT. So therefore the probability of getting 2 heads, exactly 2 heads, there is one case which is favorable, that is HH, and the total number of cases are 4. Therefore the probability is 1 by 4. So take this example. A bag contains 5 white and 6 black balls. A ball is drawn at random. The probability that the ball is white. So what is the probability that the drawn ball is a white ball? The possibility is how many cases are there? The total number of cases are 11 because 5 white are there and 6 black are there. So the total possible cases are, exhaustive cases are 11. And out of these 11 cases, the cases which are favorable for a white are 5. So therefore the probability that the ball is white is 5 divided by 11. And take this example. If x and y denote number of points obtained when 2 6-face unbiased dice were thrown, then probability of x equal to 1. So we have taken this example previously. So the probability of x equal to y becomes 1 by 6. See this example. So the probability of x is equal to y is 1 by. So the next type of probability is axiomatic definition of probability, and this definition is given by Russian probabilistic A.N. Kolmogorov. in 1933. So this axiomatic definition of probability takes few axioms, and if these axioms are satisfied by A, then simply we can say that this is true for a particular event. So that means if omega the sample space of a random experiment, a set function p defined on omega, defined on the sample space, is called a probability measure or simply probability if it satisfies the following axioms. So what are these axioms? The first axiom is probability of a particular event is always positive because probability does not take any negative value. It lies between 0 and 1. So it is more than 0 and it should be less than 1. So it does not exceed 1 and it does not take negative sign. So P of A is always positive for all A belongs to samples. The second condition is P of omega equal to 1. So probability of sample space is 1. Means what? The total probability is always equal to 1. And the third case is if A and B are, these are the two disjoint events. Disjoint events means mutually exclusive events. And mutually exclusive means what? The two events are said to be mutually exclusive if both cannot happen simultaneously. Means what? A intersection B is always a null set. Then P of A union B is simply P of A plus B, that is P of A plus P of B. So this property is also called as countable additivity because just we are adding all these respective probabilities. So take the example. So an unbiased coin is tossed twice. Find the probability that exactly one head occurs, at most one head occurs, and at least one head occurs. So what is the sample space in this case? The sample space becomes, because an unbiased coin is tossed 2 times, the sample space becomes HH, HT, TH and TT. So that remains the same for all these cases. We are interested in getting the first probability, exactly one head. In these cases, HT and TH. So the first case there are 2 heads and in the last case there is no head. So for exactly one head, 2 cases are favorable and the total number of cases are 4. Therefore its probability is 2 by 4. At most one head. There is one head or maximum there should be one head. At most means maximum and at least means minimum. How many cases are favorable? HT, TH and TT. TT means no case. These are 1 cases. At most means 1. 1 includes 0 also. So these are the 3 cases which are favorable and the total number of cases are 4. Therefore the probability is 3 by 4. And for the last case, at least one head. At least one head means more than one head is also taken into account in this case. So HH, HT, TH. So these are the 3 cases. TT is not possible because there is no head. So the cases favorable are 3. The total number of cases are 4. The probability is 3 by 4. One more example. A coin is tossed 3 times. Find probability of getting exactly one heads, at most one heads and at least one head. So exactly one heads. So what is the possibility? What are the sample space in this case? A coin is tossed 3 times. These are the possible sample space. So how many cases are there? There are in all 8 cases. HHH, HHT, HTH, HTT, TTH, THT, THH and finally TTT. So these are the 8 cases in the sample space. So exhaustive number of cases are 8. So what is the probability of getting exactly 2 heads? How many cases out of these 8 which are exactly 2 heads? So exactly 2 heads are this one case, HHT, HTH and finally THH. These are the 3 cases out of 8 cases which are favorable. So its probability is 3 by 8. So the next is at most 2 head, maximum 2 heads. So only 2 cases, TTT, there is no head, and HHH, there are 3 heads. These are not possible. All the remaining are possible. Means out of 8, 6 cases are favorable. So for at most 2 heads, the probability is 6 divided by. What is at least 2 heads? Minimum 2 heads. Favorable are HHH, HHT, HTH and TH. These are those which are not favorable. This is HTT, TTH, THT and TTT. These are 4 cases which are not favorable. So the favorable cases are 4. The total number of cases are 8. For at least 2 heads, the probability is 1 by 2. Okay. What are the results of this probability? So these are important results. So friends, you have to memorize all these results because these results are very important. Probability of an impossible event is 0. So that we have seen in the previous video. Probability of A complement is 1 minus P of A. This also we have seen in the previous video. The addition rule is probability of A union B is P of A plus P of B minus P of A intersection B. This is for not mutually exclusive cases, and in case if you put the value of B as A complement, then if A and B are disjoint, we will get the result number 2. Suppose if you put B as A complement, then A union A complement is P of omega. This is P of A plus P of A complement, and this P of A intersection A complement comes out to be 0. So therefore P of omega is 1. So 1 is equal to P of A plus P of A complement. Ultimately we are getting this result. P of A complement is 1 minus P of A. If A and B belongs to omega and A be the subset of B, simply we can get P of A which is less than or equal to P of B. If A be the subset of B, then this result holds. If B is subset of P, we can reverse this. P of B should be less than or equal to P of A. And this is the final result. 0 less than or equal to P of A intersection B less than or equal to P of A less than or equal to P of A union B, which is equal to P of A plus. So these are the important results. Friends, you have to memorize all these results because in probability theory these results plays an important. And finally in this topic there is one point which is known as a odd ratio. What is this odd ratio? If A belongs to omega and the odd ratio is A as to B, suppose this is the odd ratio, then there we can find out this odd ratio in two ways. The first way is the odds in favor of A, and the second one is the odds against A complement. And in favor of A means A. Suppose the odds in favor of A are A to B, then what is P of A? P of A is A upon A plus B. Simply we can take the first in the numerator and add these two in the denominator. A divided by A plus. And odds against A means A complement. We can reverse this. That is B to A. Therefore P of A, B divided by A plus B. In this case P of A becomes B divided by A plus B, but it is actually P of A complement. Take an example. Odds in favor of an event A are 10 to 5. Then what is P of A complement? So in favor of A is 10 to 5. The ratio in this case is 10 to 5. But it is in favor of. That is, but we need to calculate the value of A complement. A complement means finding against A. Therefore P of A complement means 5 divided by 10 plus 5. Take this 5 in the numerator first and add this 10 and 5. So the probability in this case becomes 5 divided by 10 plus 5. 10 plus 5 is 15. 5 divided by 15 is 1 by 3. So in this way we can calculate the odd ratio, whether it may be in favor of or I complement. We need